Okay, so we'll make a start. So good morning, good afternoon. My name is Alex Dorden. I'm with Siklu Communication, and I'll introduce myself. First of all, I'm the Director of Business Development for Security and Surveillance at Siklu. I'm based out of Los Angeles, California, and I'm going to be presenting to you today. And also with me on the presentation is my colleague Tim Murphy, the pre-sales manager at Siklu. Tim, are you there? Say hello.
Yeah, I'm here.
Okay, cool.
I'm here.
All right, great. Thank you very much. So we're going to be presenting to you today. Feel free to ask any questions you may have. Use the questions tool in the chat window, and we'll answer your questions as they come in. At the end of the session, there'll also be a time for questions and answers, and you'll also all receive a copy of the presentation as well. Okay, so don't feel worried about taking notes or anything like that. And you also get all our contact details as well if you have any other kind of questions you want to raise. So the things we're going to look at today, what is the agenda? So first of all, we're going to look at wireless network congestion. Is it a myth or reality? What is millimeter wave wireless, which is the technology we're going to look at today, and how this solves these problems. The applications for this technology, Siklu as a company in this space, our solutions, the support programs that we provide to both A&Es, consultants, as well as dealers, and then a question and answer session at the end. Okay. So the first slide we want to kind of discuss really is wireless congestion. Is this myth or reality? Does wireless congestion actually exist? We found over the last few years that wireless congestion is something which is becoming increasingly prevalent within cities in particular, in North America and around the globe, and primarily within cities or dense urban areas, just because there's so much wireless traffic going on. There's so many different applications which are using wireless for their means of connectivity. It could be video surveillance, it could be Wi-Fi, it could be license plate recognition, or management of traffic signals or parking meters. There's a plethora of different applications being used over a wireless network, and that's causing a problem both to cities, police departments trying to use the same wireless network to manage, monitor the video surveillance systems. And I'm sure quite a few of you have had experience of issues, problems with congested wireless networks. So the kind of question is there a fix to this? Is there a solution to this problem? So as you all know, there's various solutions available for connecting video surveillance, as one example, as one IoT, if you like, on a network. So you've got fiber. You can connect them together on a fiber network. The benefits of fiber, you've obviously got very high capacity, multi-gigabit capacity, but the drawbacks of fiber is expensive, particularly if it's not currently in place, if it has to be deployed, and deployment times can also be very prohibitive in terms of getting licenses, having to dig up the streets, so a lot of disruption. Another option is using legacy wireless networks. So when I talk about legacy wireless networks, I'm talking about your traditional 5.x or sub-6 gigahertz wireless networks, which the majority of wireless systems out there are based on. The problem with those wireless networks is they have limited capacity. They're typically limited to about 100 megabits per second in terms of throughput. And the main issue is a very much overcrowded spectrum. Because everyone uses the same type of frequencies, is also used by Wi-Fi, it's just very, very difficult to get a good, solid, reliable wireless connection. The only benefit really of this technology is low cost. It is fairly low cost to deploy. It's just not dependable and gives you very limited capacity. So there is a third solution, and this is a solution that we want to talk with you about today, introduce to you. It's fairly new to the security market. It's really only been in the security market for about 2 years really, and that's what's called millimeter wave wireless. Okay, the benefits of millimeter wave wireless are multi-gigabit capacity, so high capacity, interference free, there's no interference, no congestion within the space, and the deployment times are obviously very, very short. So the same kind of benefits as legacy wireless in terms of very quick deployment, low cost to deploy as well. Okay, so this is an ideal solution for connecting devices together wirelessly. So Tim, tell me a little bit about millimeter wave wireless.
So I understand that, Alex, did you kick to the next slide? There we go. And if you actually look at the real estate down at the far left hand of the slide, that's where you're used to working in. That is what we call the sub-6. That's like the 2.4, the 5.8 spectrum. And as you see, it's a really narrow pieces of spectrum. And if you look at specific bands like 4.9 or 24 gigahertz, these
muted
chunks of spectrum. Whereas in gigabit Ethernet in millimeter wave, we've got 8 non-overlaps, each are 500 megahertz channels, each capable of carrying a gigabit worth of information at minimum, and we've got actually devices that actually go even further than that. We have 2 sections spectrum, the V band and the E band. V band is 60 gigahertz, E band is 70, 80 gigahertz. Currently, the V band is in the existing section. The nice thing is the FCC just voted on a 5-0 vote to double that amount of spectrum. So we're going to go from 8 500 megahertz channels to up to 16 500 megahertz channels, and we could even add more in the future down the road. Back to you, Alex.
unmuted.
All right, thanks, Tim. Okay, so why is millimeter wave wireless fiber-like? So some people actually call it wireless fiber or fiber-like wireless. And there's real 3 reasons for that. First of all, and some of these things were already touched on already, no interference. It's a very, very reliable type of connection, the same type of connection that you'd get in terms of reliability from fiber. It's multi-gigabit capacity, so it actually provides very high capacity, very high bandwidth. If required, it can do a gig, 2 gig, all the way up to 5 gigabits per second full duplex throughput. So if you're trying to deliver a large number of cameras, particularly HD 4K cameras from one place to another place, you can do that very easily using millimeter wave wireless. But if you only want to deliver 1 or 2 cameras from one place of a city or a parking lot, for example, to another place, you can also do that over millimeter wave wireless, just with a lower throughput type of product. They're still then benefiting from the lack of interference. And then the third thing is very, very low latency. The latency of millimeter wave wireless in many cases actually can be as fast as, if not faster than fiber. So extremely fast, great if you've got a video surveillance system, for example, where you need to do situational awareness, PTC control, things like that, where you need immediate response times without any kind of lag. So it's great for those types of applications. So it really is a product or a solution that gives you fiber-like performance. So Tim, tell me a little bit more about how millimeter wave wireless delivers multi-gigabit speeds.
It's all about channel size, Alex. So what we're looking at is that take for example 5.8, you're essentially limited to 20 megahertz channels, meaning non-overlapping channels. And you essentially have in the US here 4, and they're talking about opening up all the way up to 8 non-overlaps potentially within the 5 gigahertz range. Whereas just in E band or in V band, we can do 250 to 1250 megahertz channels, giant channels. And if we're talking about 500 megahertz channels, we can do in both the E band and V band, the 60 gigahertz and the 70, 80 gigahertz, we can do 8 channels. And that's just on a single polarity. So just to give you an idea, on a single point, we can do 8, we have 8 non-overlapping 500 megahertz channels. We can do 2 polarities, and to reuse that same frequencies, we only have to go off and switch 90 degrees. So if you actually calculate that out theoretically, we've got 4 directions we can use, we've got 2 polarities, and we've got 8 non-overlapping channels. That means on a single site we can run up to 64 radios. And the beam is very, very focused. It's the size of a pencil. And also we use very narrow antennas, so we get a very focused high energy beam. And if you compare that to a 5.8 system, they have typical beam widths of right around 10 degrees for a directional unit. Ours are, for just our 60 gigahertz units, are 2.5 degrees. So very focused, zero interference, and a great technology to work in, especially since you're seeing today such high noise floors. Back to you, Alex.
So a question for you actually, Tim, that just came in. So with such a narrow beam angle, are you actually able to mount these radios onto something like a lamppost where they have a certain amount of kind of sway, vibration, things like that, maybe not very stable?
Absolutely. That's what the 60 gigahertz units are designed to do. Because it does have at least a 2.5 degree beam width, it does have a torsional force specification of about 1.25 degrees. So it's designed specifically so it can go on lampposts, street lights, signaling, and it really works well at street level, and that's really what it's designed to do. So it gives you that street level applications with still giving very, very high speed performance. Alex?
Okay. A couple other questions that came in on the same topic. What about the on the E-band? So less than a 1 degree beam angle. What would you recommend with regards to antenna positioning there with regards to stability?
On there, you want to have a more stable structure. You want to do a heavy non-penetrating roof mount, or you want to have it on a structure where it is bolted in, because there you don't want to see a lot of movement. You want, because there it's for a 1 foot dish, it's a ½ degree torsional force, or on our 2 foot it's 0.25 degrees torsional force. So you really want those unstable. So think of it as the 1 and 2 foot dishes as over the, above street level, and the 60 gigahertz at street level. So you get your major backhaul with the 7080, and you get the street level with the 60 gigahertz units.
Okay. Now another question which just came in, the E-band is what we call lightly licensed. So can you give a little bit more details regards to lightly licensed in terms of the licensing process and also the cost?
Absolutely. The first off, 60 gigahertz is unlicensed, okay? Again, because it just can't go that far. It's limited to about 750 meters, or about 0.43 miles, or if you want to use rough estimate, about a half mile. So, but the 7080 is lightly licensed, meaning it's licensed through the FCC. If you do it through us, it's just slightly over $200. However, you can also go through the FCC directly. There's a lot of good options, and we can go over with that with you, those options. So it's not expensive, and the license is good for 10 years. And whereas traditional microwave sometimes can take several months to get licensed, to do millimeter wave, it takes hours, that fast. Back to you, Alex.
Okay, cool. And just confirm the actual cost of that license itself with the FCC is $75 per link for 10 years. So it's actually the lowest wireless.
For 10 years, yes. If you do it directly through the FCC, yes.
All right. Thank you. Thanks for that, Tim. Okay, Tim, so tell us a little bit about Fresnel zones and the impact of Fresnel zones on wireless, if you can.
Well, Fresnel zones are like an elongated football, and even though you can see the other side of the radio oftentimes, if you have egress into that zone or that elongated football, sometimes you can't even pass the signal. Sometimes it interferes with the data rates because you have interference there. Sometimes you can't even make the connection. Because the higher frequency you go, the smaller the Fresnel zone. So the Fresnel zone, if you compare it versus a 5.8 at a third of a mile in this example, the radius is 9 feet, whereas in millimeter wave it's only 2.5 feet, less than a third the size of standard sub-6 radios. So therefore we kind of boil it down to a infomercial saying, if you will. If you can see it, you can shoot it, which is really all you have to do for an RF survey for a millimeter wave is go, can I see the other end? If I can see the other end, I can make the link. Back to you, Alex.
So what you're trying to say, Tim, is that with millimeter wave wireless, you don't have to do any kind of spectral analysis of the site to see what the frequencies are out there, what kind of channels you can use, what level of interference is going to be?
Absolutely, because the thing is, remember, it's a pencil-sized beam. So therefore, it is literally, if you can see the other side, you can shoot it. You just don't have the interference that you see in the lower frequencies. And you don't have to do the complex RF studies you have to do in the lower band license frequencies.
Okay, so you're talking about, so you can see you can shoot it. So typically what distances will millimeter wave wireless go up to?
Well, in the 60 gigahertz range, it's, as I said, it's about a half mile. In the 7080, you can go up to about 3 miles.
Okay, all right.
Back to you.
Thanks, Tim. So one of the things that often gets asked about these days, particularly with the stories of hacking going on from cameras to networks to the cloud, obviously Sony had issues with that, Target have had issues with that, is security and the actual security features or cyber security, if you like, as part of the network. So Tim, tell us how secure millimeter wave wireless is and the things that are I guess incorporated or included in the design of the product to ensure that the data, in this particular case, video data, is secure and cannot be hacked.
So the standard was originally created by DARPA. That's who actually invented millimeter wave, and they did it with security in mind. So first off, the ODUs used, and this is by purpose, all proprietary. That means Siklu can't listen to another brand of millimeter wave radio, and the other brand of millimeter radio can't listen to Siklu. In fact, even within some of our models, cannot listen to the other models. So that's first off. It's all proprietary DSPs. Second off, the beam width, as I said, is the size of a pencil. So you have to be directly in the beam path or directly behind the beam path, even to sniff the signal, to even detect that it's there. So even if you have the exact same radio and directly in between or behind the beam path, then on top of it, you have to create a synchronized transmission, again, even to start listening to the signal, which means that you have to have the password to the radio, and you actually have to synchronize the link and actually get it actively talking to the other link before you can even listen to traffic. And that's even before we start talking about AES. We do have AES encryption, both AES 128 and 256. But oftentimes people will also often say, without even AES, we are more secure than copper, and we're every bit as secure, and some people advocate we're even more secure than fiber. Back to you, Alex.
Awesome. Thank you, Tim. So the things that we've been talking about up to now really kind of describe, and hopefully you'll understand why this type of technology really does provide fiber-like network connectivity or wireless fiber in terms of a lot of spectrum available, a lot of capacity. A few of the kind of things we've not spoken about, we talked about latency a little bit, but the reliability factor is also extremely high. For example, Siklu millimeter wave radios have a mean time between failure of over 90 years. That's 90 years. So it's an extremely reliable product. So it's really creating the backbone of your network, which is going to last for far more than 10 years. So it's going to give you really a scalable network which you can add lots and lots of devices to in the future. But also something we've not talked about yet is the actual footprint. And we'll show you some examples in shortly. But the actual footprint of the solution is also very, very small. So it's again designed to be aesthetically pleasing, designed to kind of fit into a city type environment very, very well. So how about the weather? So a lot of people think wireless, issues with weather, what kind of effect does weather actually have on this technology or this type of network connectivity? So Tim, can you talk a little bit about the weather and how weather may have an impact on millimeter wave wireless?
Well, really, the only thing that affects really millimeter wave is rain. And we're not talking about light rain. We're talking about big raindrops in excess of 7 millimeters. So we're talking, think monsoon-sized raindrops. So that's what has the effect. But we do have a way to work with that, and it's called adaptive coding and modulation. And we use a hitless form, which means it's essentially transparent because it doesn't have any effect as it switches from modulation to modulation. Or if you want to think of what modulation is, it's throughput. So as a rain event comes in, it slows down the radio to the point where it can still transmit, and then as soon as that event passed, which typically these events are seconds long, it comes right back up. And it does it in a hitless fashion, which means has no effect on the link, so you can't really detect it. So it's this hitless adaptive modulation coding, or ACM, so it smoothly works through any RAIN issues that come into the link. And so essentially the end user doesn't see it. And when we design the links, we design them to very, very high reliability. You can literally design them to in excess of 5 nines. So it's a very stable, very reliable, and a very predictable link. Alex?
So Tim, just to clarify something, so you're saying when it rains, the throughput will go down, will reduce over a link. And let's say take a 1 mile link, or even a half-mile link. When it starts raining heavily, you'll lose throughput?
Well, it reduces throughput. So it reduces down, but typically like it goes from a full gig down to 700 meg up to a full gig again. So it's literally, if you're not actually watching the link itself, oftentimes you'll never even notice it.
Right, but to actually clarify, the drop in throughput will actually only take place if you have a very long distance, if you're trying to do a long range. If you have, let's say, a mile and a half.
Absolutely, there's a direct proportion.
Throughput at all.
Yeah, absolutely. It's for short range links. Oftentimes you won't see any variation in throughput. It's really only on the longer links that you really see this effect, and then that's where we use adaptive coding modulation to compensate for the rain. So it's a way of making it work and making it work smoothly even in longer distance situations.
Okay, thank you, Tim. So what other factors can affect millimeter wave in terms of weather? He talks about rain. Is there anything else that affects it?
It's really only rain. In 60 gigahertz, where you have a unique effect of oxygen absorption, that's the reason why we're limited to about a half mile, because it actually excites the oxygen molecules, so it can't go very far. Now, there's a caveat to that. The new spectrum that the FCC is allocating is beyond the oxygen absorption. It's a very narrow range in 60 gigahertz, and that will actually be outside of the oxygen absorption. Only other thing really is rain, which is very predictable. The things that don't count, which usually affects other bands, is snow. It doesn't affect it. Fog, dust, multipath, flat fading, stuff that you're usually used to dealing with does not affect millimeter wave. Makes it a very clear spectrum to work in. Alex?
All right, so you're saying when it's snowing heavily, or you got bad fog in like a port environment, or even smog or dust or smoke, that's not going to affect a millimeter wave.
You could have thick fog with a wrath from God snowstorm, and it wouldn't affect it at all.
Awesome, thank you, Tim. Okay, so maybe give me an example of where Siklu is being used, is used in an application where they've had perhaps a heavy rain kind of environment, and it's not affected the wireless performance at all.
Yeah, this is a link that was done by one of our wireless ISPs in San Francisco. It was actually measured during a storm they called Stormageddon. It was a massive 100-year storm that rolled through San Francisco. And this link was done right at our maximum distance is 740 meters that we recommend for the links. This was 750. This link was at 740, so right at max distance. And the link performed incredibly well, stayed at near full throughput throughout the storm, and the link was stable. And we rate these links very conservatively, but this exceeded even our expectations. The links really are super stable and work even in the harshest environments. Alex?
Thank you, Tim. Appreciate that. Okay, so what about the different applications for this type of technology, in particular to the security market, since most of us here on this call are security professionals. So in terms of the different applications, I mean, it's really anywhere where you don't have a connection to the cameras. Think about it, you may require or may want to use a wireless type connection. So it could be a parking lot type application or environments where you have cameras on lampposts, for example. Or it could be ports, it could be campuses. One of the largest applications really for this technology is public safety, or secured cities, or safe cities if you like. So video surveillance in in downtown areas or parks or different intersections, places like that. Really anywhere where you don't have a network connection to. You still need to have power, of course, but where you have a network connection and putting in fiber is just not an option from a cost point of view. So one of the things that we find in a lot of applications that we work with, not just in cities, but also commercial applications, that often, it's a case of they have some fiber. They have fiber to one location, maybe down a certain street or to one intersection, but not always where they need it. So this is a great solution for extending existing fiber. So you may have fiber coming in somewhere, but trying to get around the city, or perhaps you have fiber on the edge of the downtown area, but not in the downtown area itself. Then wireless is a good solution if you want to, deploy a video surveillance system without the presence of fiber. So it's kind of like a hybrid fiber wireless system, if you like. So Siklu, we've actually got quite a lot of experience in this. So we've actually deployed over 33 cities in the US already with this solution with video surveillance, and we've got many more either in the planning stages or currently being spec'd or proposed. So this is definitely a technology which is being accepted, which is being adopted by cities and police departments around the US. And I say we have lots and lots of experience, lots of reference sites where it is being used very, very well. I'm actually going to show you some examples of those. So Tim, tell me about this particular site, which was in Fort Myers in Florida, because I know you were involved in the design of this one.
Yeah, this is how Alex consumes my Thanksgiving holiday. We had, they called us up literally right before Thanksgiving. They were trying to do a proof of concept with a sub-6 vendor they couldn't get to work. This camera configuration had about 70 megs worth of draw per pole, and I think there was about 17 poles that were being deployed with this, and they couldn't get to work in sub-6. So they said, can we design a system? And so we put together, used 3 Ethernet rings, and it worked. In fact, it was up and done by New Year's. They literally needed the system turned around and up and running in 3 weeks, and we got it done. Alex?
Awesome, awesome, thank you. And how many links did you say were deployed in this system, Tim?
I think it was, 17 cameras, but I think we had 21 links. I don't remember exactly because you had to do some intermediary links with this project.
Right, and I think it was 49 cameras in total. A lot of these are multi-sensor cameras, over 100 actual sensors they were used. And I think it was about 26 links in total. So that's actually over 50 radios, all in the space of about 4 weeks or so. Yeah, so that was very impressive. So another project that we did as well in the last 12 months was a project in the town of Vail in Colorado. Vail is a ski resort, and any of you on the line who are skiers, but it's one of the top ski resorts in the US. And the city here wanted to deploy video surveillance around the downtown area, really as a public safety kind of a service to make sure there's no kind of problems or anything like that, particularly in those times when they had a lot of visitors for ski competitions. But also they wanted to provide free Wi-Fi both to tourists, visitors, as well as the residents during those times. And also there's a lot of people taking up all the available Wi-Fi basically. So they needed a good solid wireless solution to be able to backhaul both the video as well as the Wi-Fi. They looked at putting in fiber. Putting in fiber was cost prohibitive, and in fact it would have cost them over $10,000 per square foot to put in fiber because of the underground heating that they have in the town. So they put in a Siklu 60 gigahertz, which is the license-free wireless network to backhaul both the access points. They were using Ruckus access points for the Wi-Fi, as well as the Archon Vision and the Axis video surveillance cameras. And they were going back to a milestone head end. So again, that was a very, very successful deployment. Again, completely wireless deployment. So another one that we did as well earlier in the year was the city of Venice Beach in California. They had a need here for, again, public safety cameras because they had a murder of a tourist back in 2015. So they wanted to put a video surveillance system in place, but again, they didn't have any fiber going down the Venice Beach Boulevard there. So they put in a complete wireless network from Siklu to backhaul all the video. Again, they didn't want to use a 5 gigahertz wireless network because of issues with interference, with congestion from Wi-Fi applications. They wanted to go with millimeter wave, and also they needed a solution which could backhaul multiple HD, including some 4K cameras as well.
Alex, one thing I want to point out on this slide is how invisible that the Siklu 60 gigahertz unit is in Venice Beach. Visual impact was a huge deal to them, and the Siklu units have such a low profile that it looks like just another small piece of equipment, more like a service box than something that is a radio.
That's a very good point, Tim, and yeah, I appreciate you bringing that up. As you can see on the image here of the it's actually, I think it's a Samsung PTZ camera being installed. Underneath it you can see the square box. That's the actual the bottom square box. That's the Siklu radio basically, and that has a capacity of up to a gig throughput with a range of about 2,000 feet. So that's a very powerful device. So in terms of critical infrastructure, this is another very good application for Siklu. So this is the Port of Long Beach in California, second busiest container port in the US. So here they had a requirement to upgrade the existing wireless system for a couple of reasons. One, again, issues with interference and concerns about that. Also, they wanted the high capacity because they wanted a wireless network to provide basically backhaul or the failover to the fiber network, but they also had to have a system which was very, very secure. So they wanted something they could put 256-bit AES encryption on. So here we're actually providing fiber backup as wireless to the edge deployments to cameras with a range of technology, both the 60 gigahertz as well as the 70-80 gigahertz radios, with some distances up to about 3 miles in this particular project. Another application is commercial perimeter protection, or parking lot is a very similar application where you have large expanse of land. Again, you don't have fiber to the different locations because it's not there, and putting it in is very cost prohibitive. So wireless is a great alternative. This particular application here, which is a Mannheim Automotive site. Mannheim Automotive, they're the largest car auctioneers globally, and they have a number of their sites with Siklu wireless with the Vigilon cameras and VMS. And we're basically providing the network basically for the video surveillance system. This particular camera pole here didn't have power, so they actually had to put in a solar solution as well to power both the Siklu radios as well as the Vigilon cameras. So one kind of thing I want to mention about fiber. We talked about fiber quite a bit, and we do get asked quite a lot from customers. Do we compete with fiber? So are we kind of like a fiber competitor? And no, we're not. I mean, we like to work with fiber as much as possible. We love fiber. So fiber is, if fiber is available, is the best solution. You have fiber, put your cameras on the fiber network. But often fiber is not available, and putting in fiber, extending fiber, doesn't have a good return on investment for several reasons. Perhaps the cost is too great, or the time to deploy is too long. So then wireless becomes a very good solution. So really we like to call ourselves an extension to fiber. So when fiber is not there, putting it in does not make sense from a cost point of view. Think about putting in millimeter wave wireless, because it really is a fiber-like type wireless network connection. So I want to share with you a little bit more about Siklu as a company. We talked about the technology, we talked about different solutions and applications. So what about Siklu the company? What type of services do we provide? So we are actually the #1 millimeter wave company globally in terms of the number of deployments that we have. We've actually got over 40,000 installations globally in over 30 countries. So we're very, very widespread. In North America, we've got a over 50% market share. We're actually used by pretty much all the top North America service providers, as well as a number of other very large companies in North America as well, including Google Fiber, for example. So we founded 2008, so we're about an 8-year-old company headquartered in Tel Aviv, Israel, but we do have offices around the globe as well, in the US, UK, Russia, and India. And we actually own the technology. We've actually got 35 patents filed on the technology. Millimeter wave is not a proprietary technology to Siklu. It's sold by a number of other companies. We do have competitors in this market as well. So it is obviously regulated frequency. Each country has their own regulations. So very similar to Wi-Fi type frequencies, is the same type of thing. So it's not proprietary. Obviously, we have our own products in that space, and we are definitely the number one in that particular field. Okay. So this actually slide shows you. So in 2015, we had 45% market share. These are the registered bands in North America. Or the US, should I say. In 2016, actually grew up to 58%. In terms of product offering, so I'm not going to go into product slides or anything like that. We have a full range of product offering from 60 gigahertz, which we already talked about for the edge deployment. So cameras, for example, on street lights or lampposts in a parking lot, maybe a few hundred feet distance. All the way up to rooftop aggregation from one side of the city to the other side, up to about 3 miles. Okay, so we do the full range of millimeter wave products from your short distance all the way up to your long backhaul type solutions. So Tim, can you talk a little bit about the Siklu support program and what levels of professional service that we offer and provide our partners?
Well, we can actually help you and engage with you at whatever level you want. We can, if you just want to know what devices to use, we can help with that. If you want us to help you fully design the system, we can do that. We can do wireless link planning. We can help you determine what are good line of sights. We can work with you in using Google Earth as a common tool we use to help you plan out the different paths. We can do full network designs, link path calculations. On top of that, we can do certification training either through webinars or through in-person training, or in whatever works best for you. We want to make sure that your deployment is successful. And we do have essentially follow the sun coverage as far as support, 24/7, 7 days a week. So therefore, I have colleagues here in the Americas. I've also have them in the UK, Russia, India, Israel, and also over in Japan. So we actually have, if you have a problem, let's say at 3 a.m. on a Sunday, well, that's the beginning of the work week in Israel, and you probably, if you actually have a problem, you type in Siklu support, urgent on site, you probably get a call back from one of our folks out of our Israel office. And it works out really, really well by doing that. And then our goal is to provide not just your best communications provider, but be your best vendor of anything. We want to make sure that you get serviced properly. We want to make sure your calls are answered promptly, and that we give you the information that you really need.
What about training, Tim? What kind of levels of training does Siklu provide?
We do everything from just basic link alignment training all the way through full certification. So whatever need your organization has in terms of how experienced and what depth you want to go into as far as training in the devices.
Now, with regards to network design, let's say you're working with one of our partners on the design of a city or some other kind of campus. Does Siklu charge for that, or do we do it as part of the part of the service?
We typically don't charge for large network deployments, and typically if we're already in an area and we can schedule in a training for you in person, we can do that. Also trainings, just standard online trainings, we never charge for those. We want to make sure that you have the training necessary. So we try to make it as affordable and effective for you as possible, and we don't try to nickel and dime you for, like a lot of other vendors out there. So our goal is to get you to install and be happy with our radios.
Okay. A question just came in based on this design here. So this is obviously one of the designs that you put together. I'm guessing for a city. Now this looks like a mesh type deployment. Does Siklu support mesh? That's a question just came in.
It's not really a mesh. What it is, it's a series, you could call it a mesh if you wanted to, but it's really a series of point-to-point deployments that you can create redundancies like a mesh, but what we're really talking is a much higher grade called Ethernet Ring Protect. You can also use another technology called RSTP, or Rapid Spanning Tree Protocol, and I won't go into the differences here, but it allows the unit to be self-healing, and you can design a fully redundant, fully self-healing network as if it was quote-unquote a mesh, but it's fundamentally different than a mesh and much higher grade.
Okay, thank you, Tim. Link path calculation. So when we're actually putting a design together in a city, for example, tell me about this type of service that Siklu provides.
So what we do here is, well, this particular firm was primarily a security firm. They didn't do a lot of wireless, so we actually did and we'll do this for a lot of security firms. We'll provide the full wireless profile for them. So we go through, we help them plan out their links. We'll go in and calculate distances, paths. Then we'll provide them full documentation so they can present this plan to the city or whatever organization that the security firm is working with. And so it really does a soup to nuts full deployment so they can look and really put their best foot forward to their client. And so we take care of both throughput planning, availability, and we also have various tools we use that help them do this. And we, over time, as people get used to using these tools, let's say, for example, you showed Mannheim, and they were just a security firm that really didn't have a lot of experience, and we took them, and they only call us up now for technical questions. They do full planning on their own. Alex?
Great, thank you, Tim. So we have a tool available online to help with this, both help our team when they're designing a network, but also for our partners to use as well. It's called a link budget calculator. So maybe Tim, take a minute just to describe what this is and how this tool can be useful and what the information it is that it provides.
So here what you literally do is you pick out the radio you have that you want, the size of antennas you have, and then you can put in the coordinates of where the link is going to. And then what it does is it actually looks at the database of what the rain history is, so it determines what rain zone and what the rain history is, and it actually does what's called a calculated RSSI. RSSI is essentially signal strength, okay? So, and what it does, it gives you right down at the very bottom right-hand corner there, you'll see some numbers, and that literally shows you exactly what kind of throughput you can expect out of that link. And that's something that you just simply can't do in sub-6. There, it's best effort. Here is really something you can actually go to your client and say, this is what this network will be able to do for this link with this performance. So it actually gives you something that you can show them in writing what the performance of the network will do. And that's something that you can only really do in millimeter wave and in licensed links. Unlicensed, lower, sub-6 stuff simply is just best effort. Alex?
So what you're saying, Tim, is that millimeter wave wireless can actually provide, in this example here, for example, up to 5 nines or 99.999% availability. So pretty much 100% availability in any kind of weather conditions with any type of interference.
Well, yeah. In fact, if you actually look at the profile QPSK1, you would actually be achieving essentially 100% as far as our digits go out. Yes. So yes, you're absolutely right.
Right. I mean that's pretty much the same level of performance that you get out of fiber, correct?
Yes, it is. As you like to say, it is virtual fiber.
Great. Thank you. Thank you, Tim. So in summary, really then, so millimeter wave wireless, and hopefully you all see this and kind of understand this now, really does solve your wireless congestion problems because it does give you fiber-like performance with all the flexibility of wireless as well. So it gives you, for example, secured gigabits, multi-gigabit connectivity, very high bandwidth, zero interference because of the frequencies we're operating at, the 60, 70, 80 gigahertz frequencies. Quick deployment, both at the street level as well as rooftops. And Siklu, as a brand, is being successfully deployed in over 40,000 locations globally. So we really do understand the needs, the way it works, and we have a long pedigree in this type of technology. So now I'm going to open it up to any questions that anyone may have. A few questions have come in already, so please feel free to use the question box on the screen to ask any more questions that you've got. A few I've already got on here already. Tim, I'll let you answer this one. How does millimeter wave compare to air fiber, so Ubiquiti's air fiber products?
Well, they're both high capacity. They both do close to a gig, other than we have devices that can go a lot faster than that. Our basic devices can do a gig. As you pointed out earlier, we can have devices that go all the way to 5 gig full duplex. But the big difference is that air fiber is one and you're done. Literally, it has such a small chunk of real estate in the RF band that you fire one in one direction, and that's the only one you can fire in that direction at that site. You can't do multiples, and you can't do multiples off angles. You actually have to have I can't remember if it's 90 or 120. You have to be able to use to reuse that channel again with air fiber. So it's not as flexible and not nearly the capacity of millimeter wave. Alex?
Okay, what about the size as well? How does air fiber compare size-wise to like a Siklu millimeter wave?
Well, if you compare the air fiber to even our standard 1 foot, the air fiber is about twice to 3 times the size, depending on who you're talking to. It's dramatically larger. Ours is much smaller. If you compare it to our 60 gigahertz device, we are tiny compared to their device.
Okay, all right, thanks for that, Tim. Another question just came in. Reflections from buildings, water, ground, things like that. Any issues with millimeter wave?
That's multipath, and absolutely not. That's one of the beautiful things. In fact, shooting over water, millimeter wave is absolutely the best medium for shooting that. You have no reflective impact at all from the water because it's such a narrow, tight beam that, and it's such a high frequency that it sees what imperfections in any reflective surface, and you just don't have the interference from multipath that you see with other frequencies. Good question.
All right, thanks for that, Tim. That was a good one. And this is another one. I think someone needs a clarification. Do you need line of sight with a millimeter wave?
Absolutely. That's the one thing with millimeter wave is you need true line of sight. It is a line of sight technology. That means you need to see from one end to the other. But the beautiful thing is, you just need to see it. You don't have to worry about that. Remember we talked about earlier about Fresnel zones. I don't have to worry about the Fresnel zone. As long as I can see the other side, I can shoot the link, or if I can see it, I can shoot it.
So that little window of space can be quite small, is what you're saying, or quite narrow, like between buildings in a street, for example, or across the rooftop of a building, to be able to connect with the other radio.
Absolutely, and it's literally the narrowest window in the RF spectrum that we can use.
Okay. Another question came in. Do Siklu radios provide PoE output?
Absolutely. All of our radios, I think, now do provide a PoE out. The one that really does this trick amazingly well is our 60 gig radios. What they do is they have dual PoE outs, and they can actually, with their PoE out, can actually power another radio, and then you can use the PoE outs to power other devices like cameras or Wi-Fi. It's really an impressive trick. It really is. It's our 60 gig product. It can do things that it's literally one run up the pole, and then everything else is handled up at the top of the pole. Alex? Okay,
great. Thanks for that. Another question came in. How can someone buy Siklu radios? So I'll address that one if you like, Tim. So Siklu radios, we sell through distribution. On the security side of the market, we have a couple of security distributors we work with. One is Annexter, and the other one is CSC, Westco. So we work with those two security distributors. We also have a number of wireless distributors that we work with as well for anyone who deal with wireless distributors. Wincom, Tesco, Alliance, and Connectronics are our wireless distributors. However, we do work closely with our partners, with integrators, with consultants, and sometimes with end users in terms of system design, so designing the system, or support training. Just the way we sell our products, we only sell our products through distribution. We never sell directly to integrators, and we don't sell directly to end users either. Okay, so that addresses that question. Okay, that's all the questions that have come in. Tim, is there anything else you want to mention that we haven't covered already?
I think you've pretty much covered everything I can think of, but there's so much more we can talk about. But just contact us directly, either Alex or myself, and we can give you a lot more detailed information in what our capabilities are and how to apply our devices into your designs. Alex?
Great, thanks Tim. And thank you all for attending and listening today. We really appreciate and value your time. As I said, you will receive a copy of this presentation as well afterwards, as well as our contact details. If you do want to find out more and you want to talk to either myself or Tim directly, please feel free to do so. We're super nice guys, and we'd love to talk to you. So again, thank you for your time, and enjoy the rest of your day and your week. Thank you.